Okay, so this is the video for this week's homework. It's about exponential growth and stuff, and I also threw in a modulus question. That was good, wasn't it? Good. Right, so it is claimed. Oh, well, that's still working. Who knows? It's claimed that the number of plants of a certain species in a particular locality is doubling every 9 years. The number of plants now is 42. What a great number to have chosen. The number of plants is treated as a continuous variable and is denoted by n. The number of years from now is denoted by t. Two equivalent expressions giving n in terms of t are given as n is a times 2 to kt and n is a e to the mt. Determine the value of each of the constants. So we've had questions with this kind of idea before, haven't we? But there's been tables of values that you have to work out the stuff from. Here we've got two equations, but we know some things. The first thing we've got to do is work out what we know. We know that if t is 0, n is 42. That's a big thing to start with. We also know that it's doubling every 9 years. So it seems sensible just to take that bit of information and say when t is 9, n is 84. We could have done when t is 18, n is more, 168. We could have put down any values, but we just needed to get a couple of values to find out what known. So let's work with these. N is a times 2 for kt. So let's go with n is a times 2. If we're doing that one, then let's work that one. If we put t is 0, n is 42. 42 is a times 2 to the 0. So 42 is a. So we get that to start with. And notice if we'd done it in the other equation, n is a e to the mt, we would have had the same thing. 42 is a times e to the 0. So we start with a being 42. Now let's work out the others. Now we need to use our other condition. If t is 9, n is 84. So 84 is a times, 42 we now know, times 2 to the 9k. Now based on that, we've got that 2 is 2 to the 9k. And this is a really easy model, isn't it? If we've got that, then it must be that 1 is 9k. So k is 1/9. If we use the other model that we were given, that said that 84 is 42 e to the 9m, because it was e to the mt at that. 84 is 42 times e to the 9m. That gives us 2 is e to the 9n. If we take logs of both sides, natural log of 2 is 9m. So n is 1/9 the natural log of 2, and we found the 3 mystery unknowns. Very exciting. Find the value of t for which n is 100. Giving your answer correct for 3 significant figures. Thanks for moving the camera there. Is it better now? N is 100. Right. We could use either model. We've now got 2 versions of this, haven't we? It doesn't matter which one we do. Let's do the E one because we kind of know how to solve those more easily. So for part 2, we're working with 100 is 42 e to the m times 10, because we're wanting to know. No, we're not. We're wanting to find t. Where did 10 come from? MT. Before we take logs of both sides, we want to get it as 1e, don't we? So that's 100 over 42, or 50 over 21, is e to the mt. Now we can take natural log of both sides. Natural log of 50 over 21 is mt. So t is 1/nth of the natural log of 50 over 21, and you can either, it's your choice here, either stick that into your calculator, that was a 9th, stick that into your calculator and have that as a value that you've saved in a memory and use that, or on your calculator do natural log of 50 over 21 divided by 1/9 the natural log of 2. And if you do that, you get, I got the value here, 11.3. That's years, isn't it?
I do that for
Okay. You could have done that using the other equation, the 2 to the power of kt or whatever it was equation, and then taking logs of both sides and rearranging it that way. You could even, I think, probably have done that using the thing in the calculator that lets you change the base. I don't know if anybody did that. So there are quite a few ways of getting to that same answer. Find the rate. Now, as soon as we see that, that tells us something, doesn't it? That tells us that we're going to have to differentiate to find the rate of change. So we need to differentiate now. We do know how to differentiate these, but it's probably best avoided. Let's go with this version and differentiate that. N is a e to the mt. So dn by dt is a times n, e to the mt. And of course we know a and m, don't we? I'm just kind of, it's easier to write it with those there. We wanted to know the rate when time was 35. So if t is 35, dn by dt is 42 times m, which was a 9th natural log of 2, times e to the 35 lots of 9th ln2. And that, it doesn't look particularly nice. We don't need to tidy it up though. All we need to do is to find the value of that, throw that at the calculator, and it gives us, I think, 49.9, and that would be plants per year. And I've done that to 3 significant figures because it didn't actually specify other than that, did it? It's what? 49.7. 47.9. Okay, that's that just illustrates the danger of not being able to tell the difference between a 9 and a 7. Watch out for that one, kids. Don't know what happened there. Right. Question 2. Given that, now this was another past exam question that kind of caused slight puzzlement at the time. And I think it's just deceptively easy, actually, and that's what confused people. Given that the modulus of t is 3, find the possible values of the modulus of 2t minus 1. Well, all this means is that t is either plus or minus 3. If its modulus is positive 3, then t must be either plus or minus 3, and we need to think what effect would that have on the other function. If t is minus 3, the modulus of 2 times minus 3 minus 1, well, that's the modulus of negative 7, so it's 7. And if t equals plus 3, we have 2 3's minus 1, giving us the modulus of 5. If you need to use your calculator to evaluate that using the ABS button, then you're in trouble. The modulus of 5 is of course 5. So there we go. They're the two values for your 3 marks. Part B. Solve the inequality. Now the first thing we notice with this is that the gradient of these two straight lines is the same. And that tells us there's only going to be one solution, doesn't it? Because the other branch isn't going to intersect. So we instantly expect there to be just one solution. We've talked about this. You can do this either a graphical method, as Dave is about to illustrate. The graph of x minus root 2, that's a straight line gradient 1 passing through minus root 2. It's the modulus function though, so it bounces like that. There's root 2. And the other one is x plus 3 root 2, so that would cross at plus 3 root 2. And do that. It would be the same gradient though, so these branches are parallel to each other. That's 3 root 2 there. Okay? We want to find the point where they intersect. There's clearly only one point, and that point is the point where the positive one of this graph meets the negative branch of the other graph. And which way around do we want the inner? Well, let's find the point of intersection first and then deal with the other bit. So we're looking at that. Rearrange it, we've got 2x. What's that? That's minus root 2 minus 3 root 2. Have I done this right? I've got that equation wrong, haven't I? It's plus root. That was minus there. Sorry, that's a minus. There we go. Which makes that a plus. That's better. So 2x is minus 2 root 2. So x is negative root 2, which kind of feels about right, doesn't it? And if that's the case, then we need to work out, the question wanted to know when is the one that I've drawn in blue greater than the one that I've drawn in red. When is the one that I've drawn in blue above the one in red? And it looks like that's the point where things change. To the left of that, the blue one is above the red one all the time, and it will continue to be because they're parallel. To the right of it, the red one is above the blue one. So our answer is x less than minus root 2, and it was a less than one we wanted. There is our answer. And that was 4 marks. You could have squared both sides.
It looks right.
Your squared terms would have cancelled out, and you would have ended up with a linear equation being exact.
I found it easier because on the first bit I got A wrong, which was the initial bit, so I put 2 to the power of 0 is equal to 2. And so it messed up the rest of the question.
You would get your method marks. So as long as your method was correct for doing this, you get another mark for doing this bit, but not the extra mark.
What about the questions after that? Would you still get the answer not equal to the output 4 wrong?
You'll probably get 1, 2 if all of your methods correct. Okay, let's stop the video, and that's maths.